Hey everyone, today we are going to create our first video in a series on exception handling and what are exceptions. So some of the topics we're going to work through today are what are exceptions and how do exception handling, uh, how does that work versus traditional error handling. So we have exception handling versus error handling, and how are they different, and um, how do they compare. Once we do that, then we are going to get into some types of exceptions, which I have some demonstrations here on some different ways exceptions can occur or be thrown. Then we're going to introduce, the class hierarchy, and then we're going to actually work with some exception handlers. So this video is all about exceptions and kind of the intro video to exceptions. So let's start with the first question. What are exceptions? And I like to answer that with an object-oriented approach to um, handling errors, runtime errors in the program. Now, what are runtime errors? Well, you know about compiler errors. Well, compiler errors are errors that will not allow your code to compile, therefore it cannot run. But runtime errors, those are ones once your code is running and you hit an error in the program, it actually causes the program to crash, or can cause the program to crash. And so that's what an exception actually will do, is it will crash your program. And depending on the program, that might be okay. Might be okay or might not. Some programs are definitely more critical than others, and that they need to keep running. I always like to give an example of a software application that runs to monitor someone's vital signs at the hospital. So they're on life support, and they got to make sure that their heart is beating and that they're breathing, and that their vital signs, their blood pressure and all that is in the correct range. A program like that would be much more important to keep running and keep it from crashing than maybe just your homework on your Microsoft Word. If Microsoft Word would crash, well, you might have lost a couple hours of typing if you haven't saved, or maybe even 10 minutes if you haven't saved. And that program might crash, which would be much less critical than someone's life, and someone dying because you were not able to monitor their vital signs. So exceptions can cause the program to crash. That might be okay or might not. So, we get into what is exception handling versus error handling. Well, um, error handling, and we've done this before, might say, if the input is less than 0, get the input again. And you might even say, instead of saying if, you could say while the input. So, we might have a int input, and then we might ask the user system out print line, can I have input? Okay. And then you say while the input is less than 0, get the input again, right? Can I have good input? So if I run this, this is regular error handling, and that you ask for input, as long as they're giving you a -9 or negative value, something less than 0, and when they say 5, well, now it accepted the input. Okay, that's your traditional, I wouldn't even say this, traditional error handling. And it's traditional because this has been around since before object-oriented programming, and that was the only way we were able to handle any sort of runtime errors in the past. But now we have an object-oriented approach, right? And that is exceptions. And so in object-oriented programming languages, we have exception handling, which is going to include a try and catch block. And really, you're going to do the same thing. You might prompt the user over again for input. Let me change my demonstration here, and maybe because here's the deal. Input less than 0, just having something in the negative number isn't going to crash the program. But let me change this to something that might crash the program. If I say while the input equals 0, and then I'm going to do some math. So I'll say double math equals 10 divided by our input. Well, this could crash our program in the sense that if we let this math divide by 0, let's show you what happens here. Let me go ahead and comment out my while loop. And I say, can I have input? And I put in 0. You could see exception in arithmetic exception divided by 0. So first thing you see is, hey, this is an exception. An exception occurred. And if you've seen this red text over here, let me expand this a little bit down below. If you've seen this red text before, that's how you know you've come across exceptions in the past. And in this case, this is causing us to crash the program to crash. Excuse me. And by putting my while loop back in, we are not going to be allowed to put in 0. And then I might say, 5, and then it does math normally, and 10 divided by 5, so this would hold 2. So you can see how this is crashing our program, or it was crashing our program, how we use traditional error handling to solve that. Well, exception handling, and we're going to get into actually exception handlers down below, but essentially what we might do is, instead of our traditional error handling, which you saw is pretty fast and a pretty efficient way of working with this, we might put this in a try catch block, and we're going to get into this, what these different pieces are at the end of this video. And then we might say system, and then down here we'll say, can I have good input? And we might even put our just give them one chance here. And so the idea here is that instead of crashing our program right here with this line of code, instead of crashing the program, it's going to catch the exception and ask for good input again. So we give them a chance to correct the mistake. And here you could see this is the structured exception handling. This is the object-oriented approach way of doing the same thing. So if I say 0, instead of crashing the program and giving us that ugly red error message, we can put in a good value there, and that doesn't crash the program. So this is one example where someone's input was causing a program to crash, and that is definitely not the only scenario that can cause our programs to crash, therefore throw exceptions. So I went ahead and gave some different types of exceptions here that can cause our programs to crash. And just to give you an idea of just a few of the hundreds of different ways, right? And you're not going to memorize every type of exception, especially when you're new to programming. But what happens is, as you gain experience, you'll become more and more familiar with exceptions, which will help you keep your programs running by using exception handling. Basically, the more you program, the more about exceptions you'll learn, which will allow you to handle all sorts of types of errors you might encounter. One last thing is, here we've got this kind of going back. The traditional error handling, I've known companies that say all we're doing is traditional error handling. We are not going to implement exception handling. You can 100% handle the scenarios using loops and conditionals, which is fine. The structured exception handling, the scenario is that these errors should occur exceptionally, meaning they need to be the exception to the case, not the normal. Kind of a rule of thumb, if they're going to happen less than 1/3 of the time, one rule of thumb is to go ahead, if you expect the error to happen less than 1/3, go ahead and use exception handling. If you expect it to occur more than 1/3 of the time, use traditional error handling. And so that's kind of one rule of thumb. However, like I said, I've seen some companies that say, you know what, we're only doing error handling, and I've seen other companies say, no problem, we'll go ahead and do the exception handling. So that's just some theory about when do you use one versus when do you use the other. If an error is going to happen less frequently, use exception handling. If you expect it to happen, a little bit more frequently or over 1/3 of the time, use traditional error handling. So let's get into our demonstration of types of exceptions. First one, array index out of bounds. And so this would happen if we declare an array of integers, and the index values for this array would be 0 through 9. So there is no sub 10. However, this compiles just fine. If we run it, that's when we see our problem. And so up above, we're getting our output for that. But then here you see the exception in the main method. So there's an exception in the main method, and it's array index out of bounds exception. That's the type of exception. It even tells you array index 10. Again, inside of the demo class main method. So that is one type of exception. Here's another, an arithmetic exception. So I go ahead and do a print line, and I do some math divided by 0. This is the one you saw before. It's just forcingly doing 5 divided by 0, which is causing an arithmetic exception. And there you see divide by 0, again inside of the main method, inside of the class demo. So that's a second type. Here's another type, input mismatch exception. And you've probably seen this before using the scanner quite a bit. I say, how old are you? And it's accepting an integer. Now what were to happen if for that input I type in a floating point number or a number with a decimal? Can I have input? This is my prior example. Now how old are you? Well, I am 31 and a half years old, 31.5. Now you could see input mismatch exception inside of the scanner class, inside of demo.main. So you see something here. You see that the scanner next int was the method that caused the exception to be thrown inside of main. So what we have here is we have main, which calls next int. And if you actually get into this next int method, you could see that it calls a throw for method. So main calls this, next int calls another next int method, which calls a next method, which calls a throw for method. That's called the call stack. One method calling another is what that's called. So you can actually see that the exception was really thrown in this line of code inside of the scanner class somewhere. So you could see the call stack in that example. Another type of exception is a file not found exception. Um, if I go ahead and instantiate a file reader and pass it some name of a text file that doesn't exist, my.txt, uh, and then I create a scanner and try and read from that scanner, you're going to see that file cannot be found. My.txt cannot find the file specified. So a lot of times file IO can cause exceptions to occur. And so those are just a few generic types of exceptions that you might have seen up until this point. Because this is an object-oriented approach, we have a class hierarchy, which I went ahead and made this diagram for you to take a look at. And you could see that, well, we already know because of inheritance, everything inherits from object. And underneath the object class, we have a throwable class, but then here are the two main branches. Underneath throwable, we have the error class, which has a whole main branch of classes. Now, the reason why I did not have this drawn out under error is that these are typically the classes that we don't try and do anything about. For example, if your computer runs out of RAM to run your program, that's something that's a little bit outside of your control. So there are the exceptions that occur that we try and handle and keep our programs from crashing. But there are some things that are, for the most part, out of our control. And the things that are out of our control are a whole branch called error, where the things that are in our control fall under this exception class. And you're going to see you can use exception, and then you can use IO exception and runtime exception. So going back here, the last maybe arithmetic exception here, if I demonstrate that, again, you can see I have arithmetic exception. Well, let's try and work with this one, and let's try and handle that. So what I do is in a try block, the try block, I can't type today, the try block is where you put the code you expect to cause the problem. Well, this is nice and easy because we know right here, we know this line is causing the problem. And when we have a try block, you follow it up with a catch block. And a catch block, this is the code that will run if an exception occurs, or you could also say is fired in the try block. So here we know an exception is going to happen because we've hard-coded it in. And in the exception class, this is where we put our class. Remember, this is object-oriented approach, arithmetic exception. We know that's the exception that's occurring, and we're going to give our object a name. We'll just call it AE. And now we know that this is going to cause an arithmetic exception, and we know that in this scenario it'll be caught inside of this catch block, and this is the code inside of the catch. Maybe we create a log that this exception occurred, and maybe we write to the Windows error log. Maybe we write to a database, or write to an event log or database. And we haven't quite covered how to do those things, but these are things that you might do, so that you can track how often this kind of problem is occurring by logging it. And then maybe a friendly error message saying a general or an arithmetic exception happened. You cannot divide by 0. So we let the end user know, hey, maybe you don't even have to say that. Maybe just something very simple that everyone can understand, right? You cannot divide by 0. Something nice and friendly for the end user to see, and then the program can continue. And that's the main thing here, is that the program must go on. It continues on. So if we run this, we give them the input. Now it says you cannot divide by 0, and instead of crashing the program continues to run. And if there were hundreds of lines of code that would continue, the program would continue on. It would not crash, which prior to having this, right, if we take our line of code here, put it outside of a try block, the code does not go on. The program crashes. None of this other code will run. If there were 1,000 lines of code after here, none of that would run. So that's the basic on how to work with exception handlers. You put the code inside of the try block that you expect to cause the problem. You catch it with an arithmetic, or you catch it with a catch block, and then the type of exception that you think might occur goes inside of there, and then do whatever you might want to do to handle that problem, and then the program should continue.